Before the first pizza hits the oven, before the first burger melts under a blanket of cheese, America's most beloved ingredient is already on the move. Every day, millions of gallons of fresh milk race into colossal stainless steel pipes. Inside this factory, milk transforms into curds. Curds become slabs. Slabs become blocks. Blocks become the cheese Americans eat by the billions of pounds. This is no ordinary kitchen. This is one of the largest cheese factories in the United States, a place where food meets engineering at a scale almost unimaginable. Today, we're stepping inside. Narrator: cheese isn't just food in America, it's culture. 40 pounds per person every year, an industry worth tens of billions. Here, inside this facility, trucks arrive around the clock. Refrigerated tankers deliver fresh milk from dairy farms across a 150-mile radius. This single plant produces industrial cheddar mozzarella for pizza chains, American cheese slices for fast food giants, shreds, cubes, and blends used by thousands of restaurants. It processes hundreds of thousands of gallons of milk every single day. Every step is controlled by automation. Temperature, pH, moisture, aging, packaging. It's a symphony of steel, computers, and human skill. To understand how it all works, we begin with the lifeblood of cheese, milk. Narrator: milk arrives ice cold, kept at 36 to 38 degrees Fahrenheit to protect freshness. Hoses lock in, pumps roar. Tens of thousands of gallons flow into towering stainless steel silos, but not a drop is used until it passes inspection. They check bacteria count, somatic cell count, protein levels, butterfat percentage, temperature stability, antibiotics. Any trace means total rejection. Only perfect milk is allowed in. Massive 50,000 to 100,000 gallon silos store milk under constant stirring. Sensors track temperature and composition. Narrator: before milk can become cheese, it must be pure. The factory uses HTST, high temperature short time pasteurization. Milk is heated to 161 degrees Fahrenheit for 15 seconds, killing harmful microbes. Cream separators spin at extreme speed. Fat levels are adjusted with surgical precision. For cheddar, approximately 3.3% fat. For mozzarella, closer to 2%. This ratio decides how cheese will melt, the stretch, and taste. Narrator: now comes the transformation that humans discovered centuries ago, but perfected with modern engineering. Starter cultures, lactic acid-producing bacteria, are added. They begin converting milk sugar into acid. Monitors track the pH drop in real time. Then comes the key, rennet, a natural enzyme that turns liquid milk into a soft gel. Once firm, giant oscillating knives slice the gel into thousands of tiny cubes. Curd size determines everything. Smaller pieces make firmer cheeses like cheddar. Larger pieces create softer, stretchier mozzarella. Curds sink, whey rises. Whey is pumped out and saved for protein powders, lactose, and animal feed. Nothing is wasted. Narrator. Now, the curds are cooked, slowly and carefully, heated to 100 to 130 degrees Fahrenheit, depending on the cheese. This heat shrinks curds, firms them, and removes moisture. Massive paddles sweep through the vat, stirring tens of thousands of pounds. Weight drains away until nothing remains but perfect curds. Conveyor belts transport them across the factory. Where they go next depends on the cheese being made. For cheddar, the signature step begins. Narrator. If mozzarella is the king of pizza, cheddar is the king of America. In long stainless steel tables, curds pile up. Curds fuse into slabs. Workers flip them every 15 to 20 minutes, a process called cheddaring. This develops the classic firm texture and sharp flavor. The slabs are cut into fingers or chips. Sensors watch acidity. Ideal pH, 5.2 to 5.3. Salt rains down from automated dispensers. Salt stops fermentation, enhances flavor, stabilizes texture. This prepares the curds for molding. Narrator. Salted curds flow into massive block towers. Block formation. Gravity and pressure form 40-pound industrial cheese blocks. Hydraulic presses squeeze out the last drops of whey. Vacuum sealing blocks enter plastic liners or vacuum molds. Robots lift each block with precision and stack them on racks. Cooling rooms. Cheese cools for 24 to 48 hours to stabilize its structure. Temperature, 36 to 40 degrees Fahrenheit. Humidity, tightly maintained. Specialty lines, mozzarella enters a separate area. Heated, stretched, folded-shaped American cheese slices are made by blending milk plus whey plus butter plus emulsifiers into ultra-smooth, meltable cheese. Narrator. The real magic of cheddar happens in the aging vaults, aging rooms. Warehouse-sized rooms hold thousands of blocks. Temperature 40 to 50 degrees Fahrenheit, humidity 80 to 90% flavor profiles, mild cheddar 2 to 3 months. Medium 6 months. Sharp 1 year. Extra sharp 2 years and beyond. Cheese graters. Experts cut samples from blocks, evaluating aroma, texture, color uniformity, crystal formation, tyrosine crystals in older cheeses, pH levels. Each block's aging history is logged by an AI system for accuracy. Narrator. Now the cheese is ready for the form you know. Cutting machines. Huge blades slice 40-pound blocks into slices, cubes, sticks. Shreds retail-sized blocks. Shredding line shredders reduce cheese into thin ribbons. Anti-caking agents, like potato starch, prevent clumping. Packaging lines bags are opened with blasts of air. Nitrogen is flushed inside to keep cheese fresh. Vacuum sealing for slices. X-ray machines check for foreign particles. Robotic arms pack bags into boxes at high speed. This is industrial cheese at its most efficient. Narrator. Cheese needs the cold, so pallets move into vast refrigerated warehouses. Forklifts race through aisles, loading reefer trucks. Products shipped to supermarkets nationwide, fast food chains, pizza restaurants, school systems, hospitals, food service distributors. Every day, 24/7, this factory feeds America's endless demand for cheese.
rerunning the analysis on Sector 4.
The readings are still anomalous.